Greetings, this is Artie from Artifact Electronics. So we're back to the TRS-80 to take care of a few more things that we noticed last time and a couple more things that I've noticed since. So the first thing I did was I moved this to my main test bench and it promptly stopped working. It would no longer boot off the disk simulator, and I think I mentioned that I always suspected this interconnect cable between the computer and the expansion interface. The wire is extremely stiff, and when you're flexing the connectors, I think there's undue pressure put on it. So what I'm going to do is try to make a new one and see if that solves our problem. So what I'm going to do is make a new cable, and what you need for that is a 40 conductor length of ribbon cable, and this one is much more flexible than the original one, and two 40 pin card edge connectors, and a tool, a crimping tool for it. I know some of you may be using pliers to do this, and that's fine, but it's kind of easy to break the catches on the ends if uneven pressure is applied to this. So I actually try to use the tool, which I happen to have. So we got one connector in there, and what we got to do is insert. Let's see, I want to do it this way so the nice colors are on top. And when you leave it laying on the desk, it actually helps you align it instead of sliding this in freehand. This way the desk will make sure that this is aligned properly with the connector, and then you squeeze. So you can see there's a little sticking out on this end. And we can trim that off later on, but it's straight. So now we do the same thing for the other side. And one thing you have to be careful with is not to compress the top or push the top part down too much while it's going into the jaws, because then the cable won't fit inside. You can't thread the cable in. So once it's in, I kind of push the outer part away from the main connector until I am able to insert the other cable, which still doesn't want to insert. There you go. And same fashion again. It hits the desk, so it is aligned, even though there's a few millimeters sticking out. And then we squeeze it again. And that's it. You can see there's a bit of wire sticking out on each end. But again, we can trim those off later on. Let's first see if this cable does the job. And the cable's plugged in, and we got a new DOS image on the disk emulator. And there you go. So the cable looks like it's working. I'll give it a stress test too. Move around the keyboard a couple times, turn it on and off, and trim that unlovely part of the cable that's sticking out the top, and then we'll see what next to do. Okay, just for grins, let's try to boot another DOS image. Well, it's not going to move. It's not going to boot off blanks, but there is a TRS-DOS 2.3 on here. So let's see if that one comes on. And there you go. So things seem to work. And now let's talk about the things that need to be done here. So first, one thing we saw last time was there was some pretty severe keyboard bounce. And the funny thing is that that seems to have somewhat disappeared. I mean, I was at one point where the space bar wouldn't work at all and just strange things happening. But now, one of the most prominent problems was that every time I typed in print mem, the N used to bounce. So let's see. Did I just lose the A? Nope. So now, if we do print mem, it works. But I think you may have noticed some other weird artifacting happening here. Even though the camera seems to mask it somewhat, it's kind of worse in real life. But when you tap on the case, look at the display shifting in the horizontal direction. I mean, I saw that every time I hit a key, so whenever you impact it, I mean, the PCB sits right underneath the keyboard, but there's something not very good happening in here. There, yeah, you can really see it. But anyway, we're going to go inside, get rid of those stickers, attempt to clean the keys, and give a real good opportunity to find out what's causing the jitters here. Okay, let's see what's under the hood. We have 6 screws. And wouldn't you know it, there's 3 different sizes of screws. Let's see. There's long ones and short ones and medium ones. I didn't really pay attention, but I'm guessing that the front 2 are short, medium, long, but we'll find out when we're putting it back together again. So we can lift off the bottom and lift off the top. And here she is. So when these got upgraded from level 1 to level 2, one of the things was the 12K ROM, which they didn't have enough sockets on the main board for because there's 3 4K ROMs. So they just kind of stuck a daughter board here and connected it with a ribbon cable. They put in the numeric keypad and soldered a wire coming from that in, which is up here. And then looking on the back, here's the ribbon cable that they had 2 ROM sockets here. And this plugs into 1 ROM socket, and then there was a jumper, I think this one, that had to be set up properly for it to recognize the extra ROMs. And then there's another jumper that was changed to indicate when it got upgraded from 4K chips to 16K chips. And things are a little bit tight inside this board. When the case comes off, I can feel it because I think this wire here there's just too much in here that I don't think they ever counted on it being in the case, but here we are. One thing to point out is here's this flex ribbon connector that connects the keyboard to the main board. That can be a source of problems if some of the connections in here break, because essentially it is driving a bunch of rows in the key switch matrix and then reading the corresponding columns. And if any of these breaks, you will either lose a row or a column of keys, or even worse, when they're intermittent, if a column wire breaks, the column wire connects directly to the data bus, and it basically reads a floating pin, which is going to cause all sorts of key closures and weird problems happening that you'll have a really hard time figuring out. So first thing to do is to measure continuity between this board and the keyboard connector, and if minor things happen, resolder the connections, but if it looks worse, I would essentially hardwire this with a bunch of wires. But yeah, let's power it up and see if we can get it to do the horizontal dance. Okay, I put the board in the service position, just unfolded the keyboard from it, and actually the keyboard connector, which you can't see, doesn't look too bad, but yeah, still looks like everything is in place there. And this is a Z80, by the way. They did socket it, so they didn't have a whole lot of confidence in a Z80 lasting for a long time. Even though generally the microprocessor is not one of the first things to go in a setup like this. But let's go back out again and see if we're still working. I have left the expansion interface out of the equation for this test here. And we come up, and machine boots up. So if we hit the keyboard, there's no horizontal jitter here, but when we hit the main PCB, we do get jitter. And since we got it, it was happening the worst when we were tapping around the keypad, and the keypad sits under here, so there you go. Something on the board is loose. And I have my suspicions, but first, let's check voltages. Can you see the meter? Kind of, I guess. If you squint, you can really see it. But I'm going to measure the voltages at the DRAMs, because all three voltage rails are there. So let's see. Ground is pin 16, and remember, we're looking at the DRAMs upside down here. So there's 16, and 5 volts, which is VCC, is on pin 9. Am I obscuring something? Yes. 4.95. Ooh, did you see me slip? It reset the machine, so let's do this again without slipping the probes. Oh, I'm obviously measuring. There's your 5 volts. There's your 12 volts. And there's your minus 5 volts. So the voltages are all good. This guy's cooking. I mean, he is already cooking, and that's the pass transistor for the 5 volts, which really isn't unusual for a system with this many TTL chips in them, because they are LSs. low power shotkeys, but they're still drawing quite a bit of power, so kind of a miracle that this thing hasn't blown out yet. The date code on is a 79, but hey, it works and the voltages look good. So time to get into the jitter. So we notice that the jitter comes from over here. I'm going to sacrifice the TV view for a better view of the board itself. I'm going to need the voltmeter here, but it's somewhere around here, and I am looking at the screen and it is jumping. So, wow. Now I got to show you what it's doing here. This is pretty intense. Oh. I think that pots are a culprit right there. And I'm flexing the board, it's not doing it that badly, but when I tap the pot itself, I'm turning the pot right now, and I think that pot is really dirty. So let me get some stuff and spray it and see if that fixes this particular problem for us. Okay. Can you see that? Yes, you can. Yeah, it's off. The computer's off. Just for grins, let's give the other one a squirt too. And then, let me prop it up so the excess kind of flows off into the paper towel. That's not working too well. Never mind. And just work the pot. As well as the other one. Even though the other one wasn't a problem, but. So this pot, did I not mention what it is? This sets the width of the horizontal sink pulse, and this sets the width of the vertical sink pulse. So, and when you change the width of the sink pulse, I guess it starts earlier and later, and that makes the picture move back and forth on the screen. What, it doesn't focus? My finger isn't in here? Oh, okay, I better leave my finger here. And so that's what this is. Let me dry things up a little bit, even though the stuff is supposed to be safe, but it pooled a little bit on the board. So let me dry that off and see if we were able to fix our problem. So I think I got it fixed, even though, I mean, the right thing to do here is to just get a new trimmer pot. Unfortunately, I don't have an upright linear 100K pot on hand, and since my local sources for electronic parts have dried out, it's I'm going to leave it in for now. Yeah, see, it's still pretty jittery. There's small dead spots in there, but as long as it doesn't jitter, or at least doesn't jitter too much when you're hitting the board, I'm going to leave it like this for now. until I come across a part. So next, the keyboard. So I pulled one of the keys off with my key puller. It's a chip puller. And it's actually very accessible. You can see the two contacts sticking out in here. And what happens is when you push down on it, the contacts just meet. So again, the best thing would be to spray it, but it's going to cause quite a mess. So what I'm going to do is pull them off, pull the stickers off, clean the keys, and then test it again and see if that just blowing air in there fixes it. I mean, the contacts are gold-plated and they don't look like they're corroded. So I'm going to try doing it that way, and if that doesn't help, then I need to start spraying the contacts. But let's see. I'm not going to bore you with that. You basically stick the chip puller around the key and pull gently but firmly straight up, and the key just pops out. And then you clean it whichever way you need to, and then you have a good keyboard at the end. Or at least that's the way I think it should work. One other thing I found, as I was cleaning the space bar, it just acted really strange. And depending on how much pressure you put on it, if you put a little pressure it worked, if you put a lot of pressure it wouldn't. So that wasn't the key contacts themselves, but after examining the back of the keyboard, and I can't possibly show this to you in detail, but here are the two spacebar contacts, and there's a broken solder contact here. You can kind of see it there. But another thing I'm going to do is I'm probably going to touch up all of the contacts where the switches solder into the back of this board, and see if that makes any difference, because if they're cracked joints, they will also cause keys to bounce excessively. So here's the keyboard completed. Took off all the caps, cleaned all the keys, got all the stickers off. For the stickers I used something they sell in the US called Goo Gone. It's like a citrus degreaser, and the only trick, I'm sure you can find it locally if you're not in the US under different names. But the trick when using those is, once the stickers, you have to remove as much of the stickers as you can when it's still dry before spraying it, and then afterwards you got to spray them to get the residue off. And the trick is that the degreasers on this don't work like window cleaner where you just spray everything and then wipe it off immediately. You kind of got to dunk the part of the key that had the sticker on it into a small dish that has the degreaser in it and let it sit there for a few minutes. And after a few minutes it does its job, and then you can just wipe off all of the leftover residue and leftover residue. That's double. Anyway, you get the keys clean again. As far as cleaning the contacts, it was pretty successful, but what I noticed was that the main problem is not on the downstroke. On the downstroke I get no bounces at all anymore, but there are a few keys that will double trigger when you let go of the key, and that's probably the nature of the contacts, how they actually bounce when they open up. They don't bounce when you close them, but they bounce when you open them up. So I know there's a program called KB Fix out that you have to manually load or get DOS to auto load every time you boot it up, and that supposedly fixes it. I haven't found it yet, but I have a listing of it, so maybe I'll sit down with the editor assembler, type it in, and see if that does the job. Also, some of the DOSes are supposed to have it, especially new DOS, but when letting go of the key and seeing bounces once in a while still occurs, even in new DOS. So we're going to have to find that actual key fix program. So let's put it together and figure out what's next. Here we're looking at the card edge where the connector to the expansion interface plugs in, and it looked pretty clean, but I thought I'd give it another pass with IPA, and here's what the Q-tips came back looking like. So there's still a lot of residue on here, and maybe I got it now and this cable wasn't necessary after all, but it's still more convenient because of the flexible nature of the ribbon, of the material in the ribbon cable here. It's much more easy to move, to change the distance between the keyboard and the expansion interface, whereas with the old guy, this cable is almost totally rigid, and if you push the keyboard closer and make this thing fold up, it has enough tension in it to push your keyboard back out towards you again. But as mentioned, that was one of the main day-to-day problems with this machine, and hopefully with cleaning and the new cable, we got that problem entirely solved. Okay, that's it for this episode. Isn't she beautiful? Well, a bit worn. The choice of materials they used for the case probably looked really good when it was brand new, but the silver stuff tends to wear off. But then again, these got some pretty heavy use. And but she's still beautiful, she still boots up, and the only major thing I can think of doing that's remaining to be done is to actually hook this up to a real disk drive. I got some disk drives in my parts Model 3, and we'll try to see if we can hook up a real disk drive. I still have to figure out how all the drive select stuff works on here because it's different from the Model 3, and then also see if the actual disk drive and the emulator can coexist peacefully. Thanks for watching. If you haven't subscribed, go ahead and subscribe, and communicate through the thumb how much you like this episode. And do leave me a comment. I do read all of them. It may take me a while to actually respond to the ones that I think need a response. Nonetheless, they're still greatly appreciated. See you next time around.